Hello everyone, student ID is 49. Today I'm doing the block 1 for you guys to understanding the basic computer components and post PCs and softwares. First of all, I'm doing the computer and components. The left image, the left picture is what my computer that what I built by myself. So the lines are complex. So because I'm not professional for building computers. Today for here, I want to talk about the four basic things about four basic requirements for building a computer. The right side image is like what the basic thing, not basic, but what like makes a PC work. First of all, the basic computer like accept the screen, like something input and output, like the keyboard, mouse, screen. We have a motherboard. This motherboard means like every devices are connected to the motherboard, and motherboard organize all the things together and data transfer. And this is a motherboard that like the old one, but it has the functions. Like we can see the functions right there around the whole images. And this one is a newer, the made by ASUS, the extreme version. That has the memory slot, CPU slot, and the PCIe. Like we put the like here is kind of the power supply adapter, and this one is the right left top is the CPU power adapter. And this is basically about the motherboard like this. Like primary ATA controller, like this is kind of something like the ATA controller. And the power 42-pin motherboard power controller is like power supply, it's just connector, yeah. And we have like SATA RAID. This is the like this is for like to combine a RAID SATA disk, and also probably I think the right one here is the SATA 3 gigabytes. For here we have SATA, yeah, but the black one contains the like the 6 gigabytes SATA 3.0. For this PCIe slot is kind of PCIe 3.0 for 16x Gene C3. Sorry. We have a memory, but for here memory I separate into two parts: the RAM and ROM. The RAM, just like the memory we saw on the picture, the left one, the memories like we plug into the motherboard, or the right ones we have a cover on it to make it cool down, to cool the heat from the chips. For the other one, the ROM, we have a disk or SSD, a solid state disk. The general disk is function as this one, the left one. We have a plater for just like the DVDs, and then not the same one with the DVD disc, but it's similar for the same processing they're doing. So, but what is SSD? A solid state disk. In the right picture, see is all chips. So the chips doing faster than the physics disk in the left side, and it don't have some issue like physics disk, like the inside is always faster, like always slower. The inside, the data writing inside is always slower than the right side because of the physics. The inside speed is slower than outside speed. So it don't have this kind of problem, and then it is faster. It has least mistakes for when it processing. So solid state say creates this heater and has much more speed than this. But however, like if we say we have like we want a faster speed, we can make a RAID 0. RAID 0 means that we combine like several disks together, like four physics disks together to be one disk. Is it is what we call like the making rate. And this is kind of faster than before. People always use the bad products to making the rate because this is more cheaper. And if we want a faster way, this is the world most faster like one single disk SSD disk made by OCZ. It's not using the SATA line anymore. It's using the PCIe line. It is 100 faster than the one before using SATA because this is using PCIe, and PCIe has the faster transformation compared to this one, the SATA line. And for CPU, central processing unit, everybody knows it is processing the data like we collect through the memories or the input device such as the keyboard, mouse, and output the data to like screen. Central process unit is not what I mean by graphic. The graphic process unit is a different thing, but some of them has combining graphic chips inside the central process unit. So how it works? It works like this. Like we have a main memory storage, like the RAM, and then background or associated storage, just like the SSD or drivers, hard drivers. Then we translate the main memory to caching memory, which is inside the caching memory is inside the central process unit. So the caching memory means like catch the data from main memory or catch the data from the one that has already like processing. The ALU and control unit processing the data from the caching memory, and then it transfer back to caching memory and back to main memory, then back to output devices. So this is how a computer work, how a CPU work. Actually, the GPU is kind of similar, but it just contains the graphic. And the last thing, why I always say these four basic devices. So I content power supply is one of the basic devices because either of them like cannot without power supply. Power supply, like if people say why power supply is important, we just buy a power is good, but there is a problem that we have a watt, so we need to like calculate how much power supply we need to and like how much power supply it has. So this is pretty important. We have 3 levels of power supply: the bronzer, the gold, and silver. The silver has the most most saving condition. Like it could save the electricity, like power, save the power. For post PCs, there are like what I think post PCs is like the iPhone, the tablet, something like some device can wear in our body, and some device that's smart devices are suitable for the mobility is good. It is PC or it is not PC. It's the same. It's not similar with PC, but also it is similar with PC. For the market of the post PCs, we can say the laptops still the this is kind of not market, but this is the the generation. It's from 1990 to 2012. The notebook begins the first, then it's kind of the the video game player and smartphones, netbook. We mean netbook. One of netbook like the Chromebook is one of the famous netbook, the Chromebook. Tablet, wearable devices like the smartwatch. There's a smartwatch for Samsung, like the watch can control the phone. That's pretty cool. And Surface flexible displays. We can say like Microsoft Surface or something else like Kindle. Those are pretty good, pretty cool. And so the requirements of this, like the post PCs, are the same with the PCs. Like we can say this is the image about the iPhone. Like we break iPhone into parts. We have motherboards. We have the CPU in the middle of the motherboard. We can see a big chip. This is CPU, and there are memories anywhere in the motherboards. Also, we have battery, the power supply. The memories contain we are store our OS, like the iPhone OS, so we can store our images into the memory. And probably, let's say for the iPhones. And the third thing I want to talk about is Google Glass. The Google Glass is, I think that is the newest post PC device. It's a glass and it has a screen, and it has a in the bottom page, bottom image, there is a CPU, also a battery, motherboards, a chipboard, I could say. Also, there is some small memory processing for store, probably right this place, this one, or this one's the CPU. A store memory to store this the OS. This is basically about Google Glass. Google Glass, we learn this and we talk to Google Glass, and we can show there's some function like the video recorder, or we can show the Google Glass about asking for map or asking for questions. It's a pretty cool device and newest. Software, we have Google Chrome OS. This is what we want to talk about for here. And Chrome OS, Chrome browser is kind of a wireless system. This system is not basically same as Microsoft or Linux. It is a system based on the browser, the wireless, the internet. So we store everything on cloud. It's back the OS. So this is why I say Chrome OS and Chromebook are the same with PCs, because it still need to store their image, store their screen image, or there has a central processing to process their OS. It has a memory to store their OS. It's all the same. The basic requirements are the same, and it has the battery, wireless. Linux OS is the most popular OS in the world now. It has not popular, but uses the most. Linux OS, people always use this OS for programming, because it's pretty easy OS and running fast and very good. It has a very good environment for basic programming, not advanced but basic. What I want to say here about Linux OS is here, Tiny Core Linux OS. It's a world, we can say world tiniest OS in the world. It has only 5 MB megabase only 5 MB OS, just like the picture. We have 4 button in the bottom. We can add the function on the OS. So why I want to say this, because this makes the mobility of the post PCs or other devices sounds like the chips. We can use one chip to be a PC if I use this OS, because we only need 5 MB for OS. And then we just need a tiny CPU, and we can combine everything together into one chip, because this is so tiny. This OS is so tiny. And probably that's it. Thank you for watching my presentation, and hope you guys have good day. And probably this is it.